So welcome to Electronic 6LA. You are watching PYQ of signal systems of fourth semester 2024-25. Okay. In the last class we have seen for 6 mark questions. Okay. So in this lecture also we'll see some for a number of 6 mark questions. Okay. So let us start. So first the thing is that write the any four properties of DFT. Okay. So you have to write any four properties of DFT. DFT is the discrete Fourier transform. Okay. That is this also known as the discrete time Fourier transform. So you have to write any four properties of DFT. This is 6 marks. Okay. So let us start. So first property we will see the periodicity property. So if x of n and x of k means are n point DFT pair, means the DFT of x of n is your x of k. Okay. Then x of n plus capital N equal to x of n for all n. Similarly, it can be also x of k plus capital N equal to x of k for all n. Okay. This property we are going to prove. Okay. Let us see that. So prove this is the formula for DFT. Okay, discrete Fourier transform. So if the DFT of, you can see the DFT of x of n equal to x of k. So x of n, the DFT is x of k. So x of k. Okay. So this is the DFT. Okay. So now it n point DFT. Okay. So what is the formula for find DFT? So this is the formula for DFT. So it is x of k equal to summation of n equal to 0 to n minus 1 x of n e to the power of minus j 2 pi k n divided by n. Okay. This is our DFT formula. So let us put in place of where k is from 0 to n minus 1. So x of k n plus 1. So in place of k, we will be putting x of k plus n. So this is our summation of n equal to 0 to n minus 1 x of n. So in place of this k, that it is replaced by k plus n into n by divided by n. Okay. So let us multiply this. So it will be, if we multiply, it will be e to the power minus j 2 pi k n divided by n into e to the power minus j 2 pi n small n divided by n. So this n and capital N will cancel out. Okay. So we are left with e to the power of minus j 2 pi n. So this value equal to 1. Okay. So if we take this value will be equal to 1. Okay. So and that will be x of n e to the power of, only this term will remain. Okay. This will be equal to 1. Okay. So now this is nothing but x of k. Okay. This is 1. Okay. So we have proved that is x of k plus n. Okay. That x of k plus 1 n equal to x of k. Okay. So this is the periodicity property of DFT. Okay. Next is the linearity properties of DFT. We are going to prove. So if x1 of n DFT is your x1 of k, then x2 of n the DFT is your x2 of k, then x of n which is a1 x1 of n plus a2 x2 of n, which DFT will be a1 x1 of k plus a2 x2 of k. Okay. This is we are going to prove. So DFT of this one a1 x1 of n plus a2 x2 of n. Okay. So now what is the x of k? X of k equal to this one, n from 0 to n minus 1 x of n e to the power minus j 2 pi k n divided by n. So in place of x of n, we will be replacing a1 x1 of n plus a2 x2 of n. Okay. So you can see in place of x of n, we are replacing a1 x1 of n plus a2 x2 of n. Then a1 and a2 are constant, so you can take outside. So a1 is kept outside. So it is n is from 0 to n minus 1 x1 of n e to the power minus j 2 pi k n divided by n. Similarly, this one a2 into this one. Okay. Now we can see this one is your x1 of k. So x1 of k is the DFT of x1 of n. So in place of x1 of means x1 of k, this is the formula for x1 of k. Similarly, x2 of k, this is the DFT formula. Okay. So nothing, just x is replaced by x1. Similarly, this is also this is x2. Okay. This will be x2 of n. Okay. X2 of n. So this is x2 of k equal to this whole formula. Okay. Similarly, x1 of k equal to this one whole. This is the formula for x1 of k. So what is x1 of k? And the x1 of n, the DFT is your x1 of k. Okay. Similarly, x2 of n, the DFT equal to x2 of k, n point DFT. Okay. So this is called the linearity property of DFT. Okay. This is our second property. Then time reversal property. So So x1, x of n, the DFT is your x of k, then x of minus n. This is called the modulo n. Okay. So this modulo n equal to x of n minus 1. This is x of minus k modulo n. So that will be x of n minus k. So let us prove this. Okay. So DFT of x of capital N minus of n. So it will be summation of n equal to 0 to n minus 1. X of, in place of x of n, we have replaced it with x of capital N minus of n. Okay. Now let us take m is equal to n minus n. Okay. So this is the limit you can change. Okay. Next is the summation of, this is m equal to 0 to n minus 1 x of m. In place of this one, it is m. Similarly, in place of that small n equal to n minus m. Okay, this is your small n. Okay, this value is your small n value. So small n, from this you can get, it will be n minus m. Okay, so now just multiply. So it will be e to the minus j 2 pi k, e to the power minus j 2 pi k m divided n. So this will be 1. So we will left with e to the power of j 2 pi km divided by n. Okay. Now you can write x of m. It is e to the power minus j 2 pi m n minus k. We can write. Okay. Because this will be equal to 1. Okay. E to the power minus j 2 pi m capital N divided by small n. Capital N, that will be n1 cancel out. We can get e to the power minus j 2 pi m. That will be 1. So just replace, means this term. Just replace it with this one. Okay. Because this is same. Okay, you can see this term and this term are both are same. This term equal to how much? E to the power minus j 2 by m n divided by n into e to the power of j 2 by m, that is will be n sorry, e to the minus j 2 k divided by n. Okay, so this n cancel out, e to the minus j 2 by 1, that will be equal to 1. Okay, so that is why we are writing like this. Okay, so that is the DFT of x of n minus k. Okay, this is in place of small n, it is now n minus k. Okay, this is our time reversal property. Similarly, the fourth property is the circular time shift of a sequence. Okay, so x of n, the DFT of x of k, then x of n minus l. Okay, this is the, it is time shift by l units, that mod n. Okay, that will be x of k e to the minus j 2 pi k l divided by n. Okay. Let us going to prove this. So DFT of x of n minus l. Okay, that n point modulo n. So that will be this one. So this can be written as x of n minus l modulo n. That can be written as you can see, that can be written as x of n plus, just add n over here. Okay, so you can see. So actually this x of n equal to 0 to n minus 1, that is divided into two parts. Okay, we have means divided into two parts. One is part is from 0 to l minus 1. Second part is from l to n minus 1. So togetherly it will have 0 to n minus 1. Okay. So first one is this is the part 1. This is the part 2. Okay, we will separately find out the this part 1 and part 2. Then we will add this. Okay. Now this is the part 1. So you can see this is our part 1. So in place of x of n minus l mod n, we can write this one. Okay. So now it will be m equal to n minus l plus n. Okay. So let us put over here. So limit is m, that is n is 0. It is m equal to n minus l. Similarly, this is the limit. Okay. So now we can put over here. So m is from 0 to n minus l to n minus 1. Okay. So just put over a small n equal to, this is small n equal to that is this is 2 pi kn. So small n in place of small n, you can write this one. Okay. So now it will be okay, because that is actually this will be cancelled out, I think. So that is why it is written over here. So small n we can write as m minus n plus l. Okay. So this is the small n. So n and n get, you can cancel out. Okay, that is why it is written as e to the power minus j 2 pi k m plus l divided by n. Okay. So now it is second part. Okay. So second part is this one. So it is from l to n minus 1. L to n minus 1. Okay. Now it will be m is from n minus l. M is that is the n. Okay. So that is the limit we can change. Okay. So when n equal to n minus 1, that is the m, and n equal to l, this is m. So you can Here the limit is from 0 to that is the n minus n minus, because this limit we can actually, we have subtracted n over here, so it will be 0. Okay, then if we subtract that n, it will be n minus l minus n. This is written over here. Okay, so now it will be this one. Okay, in place of n you can write m, this is written over here, m minus l plus n. Okay, this is the value of n. Now it will be e to the power, because n you can cancel out this n, so that will be e to the minus z 2 pi k m plus l. Okay, now we can add these two parts. Okay, we can add these two parts. So now we can change the limit also, because it is 0 to n minus 1. You can see the this part is same. Okay, this part is same. Okay, so that is why we can change the limit. Okay, so it is 0 to n minus n. We can add this limit. Okay, this part and this part both are same. Okay, next it will be, you can take outside e to the power minus j 2 pi kl divided by m. Okay, now it will be thus dft. Okay, so it is the, in place of n you can write n over here, so this is the e to the power of j minus 2 pi kl divided n into x of k. So this is the circular time shift property. Okay, this is our fourth property. Okay, so we can means write for number property. So I have included some more. Okay, so it is circular frequency shift. So x of n, the dft is of x of k, x of n into e to the power j 2 pi ln divided by n, the dft is your x of kl minus l mod n. Okay, so let us prove this. So dft of x of k and x of n e to the power minus e to the j 2 pi ln divided by n. So it will be, just put the formula in place of x of n. This is the dft formula. Just in place of x of n, we are having x of n into this much. So it is written over this one. Okay. So the DFT, what is the DFT formula? So DFT formula is your x of n, the DFT is your x of k, which will be summation of n equal to 0 to n minus 1 x of n e to the power of minus j 2 pi k n divided by n. This is the DFT formula. So in place of x of n, now it is whole term. X of n is this one. Okay, that is all. That is all means replaced. X of n into e to the power of j 2 pi ln divided by n. Okay, this is our x of n. Okay, so into this one, this thing. Okay. Next one is your, you can multiply this or simplify this, it will be this one. Okay. Now it will be, you can write n, you can add n, because n and n gets you can means you can have this is the same result. This equation and this equation both are same. Okay. So now this is the dft, that is the x of n plus k minus n. Okay. This is the n plus n minus n. So we have proved this circular frequency shift. Then we have the complex conjugate property. So x of n, the dft is your x of k. Then x star of n, the dft is your x star of minus k mod n. That will be x star of n minus k. So let us prove this. So dft of x star of n, it is the x star of n, it is e to the power minus j 2 pi k n divided n. So now this whole thing star is in outside the bracket. You can see. So this star means it will be star n. This is plus minus, that will be plus. Okay. So now it will x of n e to the power minus, we can write this way, because n and n can cancel out. We can have this same term. Okay. So it is e to the power j 2 pi n. This is the k. Okay. This is the whole term. Okay. Divided by this one. So we can see this is the dft. Okay. Of x star of n minus k. Okay. So we have proved this complex conjugate property. Okay. So we can write at least 4. Okay. So this is the multiplication of two sequences. The x1 of n, the dft is x1 of k. x2 of n, the dft is x2 of k. Then you can multiply x1 of n into x2 of n. Then it will be the dft is x of n k. It will be 1 upon n x1 of k. This is a circular convolution with x2 of n k. Okay. This is the property. Then we have the circular convolution property. If x1 of n, the dft is x1 of k, x2 of n, the dft is x2 of k, then so x1 of n circularly convolved with x2 of n, that dft will be x of k, that will be x1 of k into x2 of k. Okay. So these are the properties of dft. So in this question you can write any 4 properties of dft. Okay. Next one is the second question is that is the compute the continuous time Fourier transform. Okay, so you can see continuous time Fourier transform of the rectangular poles. Okay, so rectangular poles that we can prove means find out the continuous time Fourier transform of the rectangular poles of amplitude a, which is ranging from -5 to 5. Okay, So let us see that. So this is the Fourier transform. So x of omega equal to minus infinity to plus infinity x of t. X of t is a rectangular force of amplitude a. It is ranging from minus pi to pi. Okay. So you can see this is the amplitude is a, x of t equal to a we have written, and the amplitude is from amplitude is a, and the limit is from minus pi to pi, because this is a range from minus pi to pi is given. Okay. So let us integrate this. So it will be a is kept outside. It will be e to the minus j omega t divided by j omega. Limit is from pi to minus pi. So let us put over here pi. You can in place of t you can write pi. Similarly, in place of t you can put minus pi. So minus minus it will be plus. Okay. You can see minus pi, it will be minus minus, it will be e to the j omega pi. Okay. Now, so then let us solve this. So this is the e to the power of, so what is the sin theta? Sin theta equal to e to the power of j theta minus e to the power of j theta divided by 2j. Okay. Okay. So now it will be uh, this place divide, you can write e to the power of j omega pi minus of e to the power of minus j omega pi, that will be a by j omega, okay, divided by uh, 2j we can multiply numerator and denominator. Okay, so you can multiply 2j, so I can have this j cancel out, so it will be 2a by omega, then it will be sine omega pi. Okay. So this is sin function. So in place of sin, we can now multiply pi. Okay. So it will be 2a pi. Denominator and denominator we can multiply pi. So it will be omega pi. So it will be, this function is a sin function. So it will be 2a pi sin omega pi. Okay. So here 2a pi sin omega into pi. Okay. So this is our second question, I think. So third question is your find out the autocorrelations of these two sequence. Auto means the same sequence. Okay. So find out the autocorrelation of this sequence 1 to 5, 2, minus 1 and 4. Okay. So x of n equal this one. So what is the autocorrelation? This is x of n star of x of minus n. So this is the formula for autocorrelation. This is x of n we have plotted. So it is a 0, the value amplitude is 1, at 2 that is 2, likewise, and 5. At 3 it is 2, then 4 it is minus 1, 5 it is 4. Okay. So now this is x of minus n. So we have plotted x of minus. So you can see the starting point actually. So the starting point of x of n. What is x state of starting point of x of n? It is starting point. Starting point is 0. It is starting from 0. So x of minus n, what is the starting point? The starting point you can see is minus 5. Okay. The starting point is minus 5. Okay. So the starting point of, that is the y of n or r of x, y, l. What will be the starting point? Lowest between these two. So we can start from the sequence that is minus 5. So it will start from minus 5. Okay, this is the starting point. Okay, then of the output. Okay, or output means autocorrelation. Similarly, ending point. So in this case, you can see the sequence is end at 5. In this case, the sequence is end at 0. So you can take highest of these two. So highest is your 5. Okay. So the starting point is your minus 5 and ending point is 5 for this sequence. That is the autocorrelation. Okay. So let us check that. So this L is, we can start from L is, we can start from minus 5. Then it will go up to L equal to 5. Okay. That is the thing. So how to find out the starting point and ending point of this sequence. Okay. So next one, this is I have told you, the lowest point is at minus 5 and highest point is at 5 in the output sequence. Okay. So this is the formula for final for the autocorrelation. Autocorrelation means the same sequence. Okay. So x of n into x of n minus l. So that is r of x 0. It will be minus infinity to plus infinity x of n. The same sequence will be multiplied because this is 0. You can put over 0. L equal to 0. That will be x of n into x of n. Okay. So this is your x of n. So this then it will be multiplied with same x of n. So this amplitude 1, again it will be multiplied with 1. So 1 into 1, 2 into 2, 5 into 5, then 2 into, all will be added. Okay. So that is the thing. You can see this is 1 into 1, 1, 2 into 2, 4. There is 5 into 5, that is 25 thing. 5 into 5 is a 25. Okay. 5 into 5, that would be 25. Then 2 into 2, that would be 4. Then minus 1, minus 1 into minus 1. Okay, that will be 1. Okay, that is plus 1. Similarly, 4 into 4, that will be 16. Okay, so we can add this one. Okay, so it is actually 51. Okay, the answer is 51. So it is written, rightly written. The answer is 51. Okay. Similarly, we can put here L equal to minus 1 or L equal to 1. You can see. So first we have put it L equal to 1. Okay. So L equal to 1 means this x of n minus L. So L is now 1. Okay. So now it is x of n minus 1 can be obtained by shifting x of n towards the right by 1 unit in time. So this is our x of n. So we can shift towards the right. Okay. So you can, this sequence is starting at 0. This sequence will be starting at 1. So you have means shifted this sequence towards the right. Okay. So now it is 1, 2. Amplitude is remain constant. Only the time shift. Okay. So this is 4, 5, and 6. Okay. This is our x of n minus 1. Okay. Now we can means what we'll do, you can multiply. So x of n will multiply with x of n minus 1. Okay. So this is 0. At 0, this is 1. There is no time that is 0. So we can, that will be 1 into 0. So we can take only the common values. Okay. So this 2, 2 into 1. Similarly, 2 at 2 it is 5. So 5 into 2. Similarly, at 3 it is 2. So 2 into 5. Okay. Similarly, 4 in 4 at 4 it is minus 1. So minus 1 into 2. And at 5 it is 4. So 4 into at 5 it is minus 1. So 4 into minus 1. So that is, you can multiply and add. So it will be 16. Similarly, L for L equal to 2, so it will be x of n minus 2. So x of n minus 2 is obtained by shifting x of n minus 1 towards the right by 1 unit in time. Okay. So this is how x of n minus 1. So you can shift towards the right, only the time base. You can see it is starting a 1, that will be starting 2. Okay. So you can shift the sequence towards the right. Okay, by 1 unit in time. Then you can multiply this. Okay, so this is the multiplication result. So you can see this is 2. So 2 it is it is 1, and 2 it is 2. So 2 into 1, that is will be 2. Okay, I can check this one. Okay. So at sorry, x, it will be multiplied with x of n. Okay, x of n, it will be multiplied with x of n. Okay, so that x of n I have written. No, I have not written it. So x of n you can multiply. So x of n, what is x of n? So x of n equal to at 0 it is 1. Okay, x of n at 0 it is 1. So at 0 it is 1. So at 1 it is this is 0, 1, 2, 3, 4, and 5. Okay. So at 0 it is 1. Means it is 0, not there. So 1 it is 2. So at 2 it is 5. So 5 into 1, that will be 5. Okay. So at 3 it is 2. So at 3 it is, at 3 it is 2. Okay. So 2 into 2, that will be 4. Okay. Similarly, at 4 it is 5. At 4 it is minus 1. So it will be minus 5. Okay. Similarly, at 5 it is 4. At 5 it is 2. So 5 into 2, 5 it is 4. So 4 into 2. So that will be 8. So it is 12. Okay. So in this case also you can see, so I have told what that is x of n. So this is right. So x of n is multiplied by x of minus n minus 1. Okay. So x of n is here multiplied with x of n minus 2. Okay. So this will be 12. Similarly, this L equal to 3. So this is our n minus 3. So n minus 3 is obtained by shifting x of n minus 2 towards the right by 1 unit in time. So this is x of n minus 2, that will be shifted towards the right by 1 unit time. This is your x of n minus 3. Okay. So that will be the result. So x of, I have not means drawn the x of n. Please draw the x of n. Okay. So x of n, that will be multiplied with x of n minus 3. Okay. So x of n means it is 0, 1, 2, 3, 4, and 5. Okay. So at 3, the common points are 3. So at 3 it is 1. At 3 it is 2. So it will be 2. Okay. Similarly, at 4 it is 2. At 4 it is minus 1. So 4 in that is the, at 4 it is minus 1. At 4 it is 2. So that will be minus 2. At 5 it is 4. At 5 it is 5. So 5 into 4, that will be 20. So it will be 20. Okay. Similarly, at L equal to 4, it is the formula. So x of n minus 4 is obtained by shifting x of n minus 3 by 1 unit time towards the right. So you can see this is our uh, x of n minus 4. That x of n minus 4 will be multiplied with x of n. So what is x of n? You can write over here. It is 0, it is 1, 0, 1, 2, 3, 4, 5. So what is the common point? Common points are 4 and 5. So at 4 it is minus 1. So minus 1 into 1, that will be minus 1. Similarly at 5 it is 2, at 5 it is 4. So 4 into 2 it will be 8. So it is 7. Now at L equal to 5 you can x of n minus 5 you can draw. So this is the shifting x of n minus 4 towards the right. What the common points are there? So it is 0, 1, x of n, 3, 4, 5. So common points are this one, 5 and 5. So you can 4 into 1. So that will be 4. Okay. It is our at L equal to 5. Similarly, we can we can calculate for negative values of L. So L equal to minus 1, this is the, we can shift the signal towards the left. Okay, this signal will be shifted towards the left. Okay, we can see x of n plus 1 is shifted towards the left. So it will start with minus 1. So this signal will be shifted towards this side. So this side. Okay. Now we can multiply. Okay, so I can multiply. So you can multiply, that will be x of n with x of n plus 1. So x of n this one. So you can multiply the common points. So you can see the common points are 0. So at 0 it is 1, at 0 it is 2. So 2. So at 1 it is 2, at 1 it is 5. So 5 into 12. At 2 equal to 5, it is 5. At 2 equal to 2. It is 5 into 2, it will be 10. Similarly, you can calculate minus 2 minus 4, it will be 16. Okay. So then likewise you can calculate L equal to minus 2, that will be more x of n plus 1 is obtained by, so x of n plus 2 is obtained by shifting x of n plus 1 towards the left by 1 unit in time. Then you can multiply with x of n. So please multiply it with x of n. X of n will multiply with x of n plus 2. The result will be this one. Okay. So here L equal to minus 3, this one. So it can be obtained by shifting x of n plus 2 towards the left by 1 unit in time. So you can see, now multiply x of n with x of n plus 3. This will be multiplied with x of n. Okay. The result is 20. Okay. Similarly, at L equal to minus 4. Okay, L equal, this is the formula. So x of n plus 4 is obtained by shifting x of n plus 3 towards the left by 1 unit in time. Okay, this is your x of n plus 4. So it just multiply it with the x of n. So for x of n it is 0, 1, 2, 3, 4 and 5. So the common point you can see 0 and 1. Okay. So 0 means it is minus 1. So it will be minus 1 into 1 plus 1, it is 2. So 1 into 4. Okay. So it will be minus 1 plus 4. Minus 2. Okay. Okay, sorry. So it is the x of n will be multiplied with x of n plus 4. So you can see this is the x of n. So 0, 1, 2, 3, 4 and 5. The common points are at 0. At 0 it is 1. So 1 into minus 1. Similarly at 1, sorry, at 1 it is 4. At 1 it is 2. So 4 into 2 it will be 8. Okay. So 8 means it will be 7. Okay. So this will be 8. 4 into that is will be 2. 4 into 2. Okay. So it will be 7. Okay. So likewise, you can obtain L at L equal to minus 5, you can obtain. Okay. So x you can see only the common point is equal to 4. So it will be only 4. Okay. So this we have calculated all the values. Okay. From minus 5 to plus 5. Okay. Let us add this. So this is the x of n, the out of correlations. All are values. These are values of the out of correlation. Okay. From minus 5, this is from minus 5 to 5. Okay. So let us check this whether our answer is correct or not. Okay. So we can write here x of n. We can write here either x of minus n. Okay. Then we can multiply this. Okay. So we can multiply this with this one. 1 is multiplied with this one. Then 2 is multiplied with this whole things are there. 5 is multiplied with this whole things. Okay. So all will be multiplied. Then diagonally you can add. So first one is 4. So you can see this is 4. Okay. First one is 4. So this is 4. So now this is 8. 8 minus 1, that will be 7. Okay. This is 8. Similarly, this will be 8. So this will be 20. Okay. Then this will be adding. So it will be 12. So this cancel out 5 and minus 5. It will be 12. So now this will be 20. 20, this 2 and 2 cancel out. So 20. 20 minus 4, that will be 16. So now this will be 8. Okay, it will be 51. Then it will be 8. 20, that will be 2 to cancel out. 20 minus, that will be 16. 51, 16, 12, 20. You can add. Okay, so you can add. This will be 12. This will be 20. This is 7. That is 4. Okay, so our result is correct. So this you can use for checking. Okay, last question will take. So find the Fourier transform of a triangular signal of amplitude 5 volt and the duration is 2t. Okay, this is symmetric about the y-axis. The triangular signal is symmetric about the y-axis with amplitude is how much 5 volt and the duration is 2 volt. This is given. Okay, so that signal we assume that it exists from minus t to plus t. That is the duration is 2t. So in mathematical form, this is the triangular signal we can have 5 into 1 minus t by capital T. This is the mathematical expression for the triangular wave. Okay. So now it is maximum at t equal to 0. Okay. So it decreases at t equal to plus minus 80. So this is the triangular wave that is given. Okay. So let us put this is symmetric about the y-axis. You can see it is symmetric about the y-axis. So x of t equal to x of minus t. Okay. So it is a even signal. You can see this is a even signal. Okay. Let us find out the Fourier transform. So x of omega equal to this one, the Fourier transform. So by Euler's formula, e to the power minus j omega t equal to uh, cos theta minus j sin theta. Okay. Now x of omega equal to put in place of e to the power minus j omega t, it is cos omega t minus j sin omega t. So x of t cos omega t dt minus j into sin omega t x of t. So this part equal to, because this is the, you can say even this signal is a x of t. This is a even signal. Means these things will be 0. Okay, this things equal to 0. So that is the why it is written as x of omega equal to x of t cos omega t dt. Okay. So next one is for any even function, this is the formula e to the power of minus infinity plus f of t dt equal to twice into 0 to infinity f of t dt. Okay. So x of omega equal to twice of, you can see 0 to infinity now. Okay. Not minus infinity, we can write 0 to infinity without 2 it will multiply. Okay. So now this signal is exist for minus t is less than minus equal to capital T. So this limit is from 0 to t. So you can x of t you can put, that is the triangular, the mathematical form of the triangular. Then you can integrate. So 5 into 2 equal to 10. So 1 minus t by t cos omega t dt. So this is the cos omega t dt into 1 upon t kept outside. So it is t into omega t. So this first integral is your I1, that is sin omega t by omega. So 0 to 2 you can put over here. This t replaced by capital T. Second integral equal to this one. So you can put the Euler formula. Okay. UV method. Okay. So you can get this one. Okay. So then add this I1 and I2. So you get this result. Okay. So sin square theta you can put over here. Okay. So that will be our result. So this one is your x of omega. Okay. So 5t equal to this one. Okay. This is the Fourier transform of a triangular wave. Okay. Just go through the steps. Okay. So these are the for number of 6 mark questions. Okay. So thank you for watching this video. These are our references. If you have any doubt, you can free to ask me in the comment section. Okay. Thank you all. Have a nice day.